Okay, number 171 in your classwork for quadratic equations asks you to use u sub for the following equations. So I have 6x to the 6th plus 13x to the 4th plus 6x squared equals 0. So each of these terms has a common factor of x squared. So I can pull out an x squared. That'll give me 6x to the 4th plus 13x squared plus 6 is equal to 0. Then using the zero product property, right, either x squared could equal 0 or 6x to the 4th plus 13x squared plus 6 could equal 0. And so from this one, right, it's easy to see that x has to be equal to 0. But for this one, it's going to be a little more challenging to find the roots. So first, we have to rearrange this with a u sub. So if I set my u equal to x squared, right, then this equation becomes a 6u squared plus 13u plus 6 equals 0. And this I can factor with, or find the roots with the quadratic equation. Or we could factor it, actually, because we're looking for something that multiplies to this a times c, which is 36, but adds to 13. And if we use 4 and 9, which 4 times 9 is equal to 36, and 4 plus 9 is equal to 13, then it looks like we can factor this. So if I group my terms, I can group 2u, I can pull out a 2u from these two, so that'll leave me with 3u plus 2, plus factor out a 3 here, 3, then I'm left with 3u plus 2 is equal to 0. So then I have 2u plus 3 times 3u plus 2 equals 0. And so my u, if we use the zero product property again, my u here could be negative 3 over 2, or it could be a negative 2 over 3. And if these are my u's, then I have to substitute the u's right back into my equation for relating u to x. And so negative 3 over 2 could equal x squared, and negative 2 over 3 could equal x squared. But in both cases, if we take the square root of both sides to find x, right, we can't take the square root of a negative number. It's undefined. So these solutions are not existent. And so basically, we can only have the one case where if x squared is equal to 0, then x must be 0. So I only have 1 0 in the solution, and that is when x equals 0.